Alright, welcome back. This will be our last video to go over a few more things that are going to be on the final exam that you're going to see. Talking about probability and counting techniques. So, I'm going to start off talking about counting techniques. And this is like if we're making a decision and then another decision after that. And if our choice doesn't affect our next choice, we call those independent. So, when I say that we have independent events, that means that making the first choice doesn't affect the second choice. So, in order to count the different ways we have of doing something that occurs in different stages, we're going to use what's called the multiplication principle. So the multiplication principle says that for independent events, if one step can be done in m different ways, and the second step can be done in n different ways, then we're just going to multiply m times n to get the total ways of doing it. And we're going to look through these examples. So the first example, say you have 6 shirts, 4 pants, and 2 pairs of shoes. Using this, and assuming you don't care if the things actually match, how many different outfits can you make? Now, one strategy would be you could actually draw a tree diagram. So your first choice, you have 6 different options. 1, 2, 3, 4, 5, 6. Imagine you got this tree, and then off of each of those, you're going to have 4 branches coming off of each of those. After you make the first choice of the shirt, then you choose the pants, and then off of each of those, you're going to have 2 pairs of shoes. So the total number of outfits is going to be 6 times 4 times 2. 6 times 4 is 24, times 2 is going to be 48 different ways of making an outfit. And if you go to some restaurants like TGI Fridays or maybe Olive Garden or whatever, and say they have a special where you can choose one of 3 salads, 5 entrees, one of 5 entrees, and one of 2 desserts. How many different meals could you have from that? So again, imagine you're on this and you're making a choice of a salad. You got 3 different choices. Off of each of these branches, you would have 5 different choices, and then off of each of those, you would have 2 choices for desserts. So again, the process is going to be 3 times 5 times 2. 3 times 5 is 15, times 2 is going to give us 30 different meals that we could eat there. The last example, a student ID is the student's first initial, last initial, and then 2 digits. So this one's a little bit trickier. So we got a first initial, we got a last initial, we got 2 digits here. And think about all the possible combinations that we could have. So how many different ways can we choose a first initial? Well, first initials are letters, so it's going to be 1 of 26. And then we could repeat, so maybe their first and last name start with the same letter. So we could have 26 ways of picking a last initial. And then how many digits do we have? So you might think it's 9, 1 through 9, but you're forgetting 0, so it's actually going to be 10. And then we could have a repeat of 10. So this one, probably need to type in the calculator. This one gets a little bit bigger. We've got 26 times 26 times 10 times 10. And this number comes out to 67,600 for total student IDs that we would have. So that is the multiplication principle, and that's how you can count up different ways when you have multiple steps. Now we're going to talk about probability. And probability is the mathematics of chance and measuring uncertainty. It's going to be a ratio. Sometimes we can talk about experimental versus theoretical probability. In this course, we're basically talking about the mathematical or theoretical probability. So it's going to be a ratio of the favorable outcomes, what we want to happen, out of what can happen, out of the possible outcomes. So this is the total number of outcomes. So what we want or what we desire out of the total. So a lot of these probability questions have to deal with dice and drawing cards or with coins. So on your final exam, you're going to have some examples with dice and you're going to have some examples with coins. Some things to remember about probability is probability, again, is a ratio between 0 and 1. It's a fraction or a decimal between 0 and 1. If it has a probability of 0, that means that it is mathematically impossible to happen, so it's not going to happen. If it has a probability of 1, that means it is certain to happen. So a few examples. What is the probability of rolling a number greater than 7 with one die or dice? So if you look at a dice, it's got the numbers 1 through 6. So it's got like 1 and then 2 and then 3 and so on. So what's the probability of rolling a number greater than 7 with one dice? Well, it can't happen. So there's 0 ways of doing it. There's only 6 possibilities. 0 divided by 6 gives you a 0. It's a probability of 0. It's never going to happen if you're just rolling one standard dice. What is the probability of rolling a number less than 7 with one die or dice? Well, again, the numbers 1 through 6 appear on the dice. Each of those is less than 7. So there's 6 ways of doing it out of a total of 6. 6 over 6 reduces to 1. So rolling a number less than 7 is always going to happen, and it has a probability of 1. What is the probability of rolling a prime number with one dice? So if we label these 1, 2, 3, 4, 5, 6, those are the different events that can happen. We could roll a 1, a 2, a 3, a 4, a 5, or a 6. Which of those are primes? Now, got to remember the definition of prime is one that has exactly 2 factors. So exactly 2 factors. So exactly 2 factors, namely 1 itself. So 1 is not considered a prime, but 2 is a prime because the only thing that divides into 2 is 1 and 2. 3 is a prime. 4, not a prime because 4 is 1 times 4 and it's also 2 times 2. And then 5 is another prime. So 6 is not a prime because it's 1 times 6 and 2 times 3. So we got 3 ways out of 6 total ways. So the probability would be 1/2 or 50%. When we get to rolling 2 dice, now this is pretty common if you play a lot of board games, you play Monopoly, you might want to know what's the probability, of rolling doubles, what's the probability of rolling a 7. We can find that by making a table. So basically I make a table like this, and the numbers going across here, 1, 2, 3, 4, 5, 6, those represent, 1 die. And then the numbers going down this column, 1, 2, 3, 4, 5, 6, those represent the numbers on another die. Maybe think of this as 2 different colors. So, maybe this is the green die, and if you have a red die, it's easy to tell the difference between them. If they're both white, it's kind of harder to tell. But if you had, different colors of dice, you'd be able to tell. So if you roll a 1 on the green and a 1 on the red, you get a total of 2. A 2 on the green and a 1 on the red would give you a 3. So this is just going to be an addition table. We just add up the numbers on each dice, the green one and the red one. So it's going to go like this. And then this box right here would represent rolling a 1 on the green and a 2 on the red. So that's going to add up to 3. And we add up going across. What about this box? What does that represent? Well, that's going to be a 2 on the green and a 3 on the red, so it would be a 5. So let's fill in this row. And we got 5, 6, 7. So should be able to fill this in quickly and reproduce it easily. Again, it's just basically a little addition table. And we got 7, 8, 9, 10, 11, 12. So using this table, we can now answer questions like, what is the probability of rolling a 7? Or what's the probability of rolling a 2? So what's the probability of rolling a 3 with 2 dice? Well, how many different ways can we do it? Well, we can do it this way, a 2 on the green and a 1 on the red, or we could do it this way, a 1 on the green and a 2 on the red. So there's 2 ways. Out of how many? So how many numbers did I fill in? So I filled in 6 in each row. There's 6 rows, so we did 36. You make sure you reduce it, so that would reduce down to 1 over 18. Which number is most likely to be rolled? If you said 7, you are correct. So if you look here, you got 7 all along these diagonals. So the probability of rolling a 7 is going to be the most likely, because there's 1, 2, 3, 4, 5, 6 ways of doing that. 6 out of 36 reduces to 1/6. What's the probability of rolling a 12? Again, there's only one way of rolling a 12, and that'd be 1 out of 36. And I could also say, what's the probability of rolling a prime number? So how many primes do we have? So here let's highlight our primes. So 2 is a prime, 3 is a prime, 5 is a prime, 6 not a prime, 7 is a prime. So we'll circle all those. 8 not a prime, 9's not a prime, 10's not a prime. Oh, 11, that's our last prime. And how many did I circle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We got 15 out of 36. I can divide that by 3. That's 5 out of 12. So 5/12. A little bit less than half. So that's how we can find the probability rolling 2 dice. The other type of question you're going to have for probability is flipping a coin. So a coin is flipped 2 times. How many different ways can this be done? Well, what can happen on the first flip? You can get either heads or tails. What can happen on the second flip? Again, you have a heads or tails. So using what we talked about first, this multiplication principle, we've got 2 choices for the first flip. We got 2 choices for the second flip. So 2 times 2 should be 4 choices. What I do on the first flip doesn't affect what happens on the second flip. So what are these? We can write them out. So the first flip could be a tails, and then we could have a heads. It could be a tails, and we have a tails. Or the first flip could be a heads, and then the second flip could be another heads. Or the first is a heads and a tails. And you can see that labeling it, that exhausts all the possibilities. And once you got them written out, then you can figure out some probability questions like, what is the probability of getting at least 1 head? So I look back at the list here. Probability is what we want out of the total number. So how many show us at least 1 head? Well, this has at least 1 head. This one has at least 1 head. It's got 2 actually. This one has at least 1 head. So that's 3 out of a total of how many? 3 out of 4. So the probability of rolling at least 1 head, if you'll flip a coin 2 times, is going to be 3/4. All right, here we're talking about flipping a coin, and this time a coin is flipped 3 times. How many different ways can this be done? So if we flip a coin 3 times, we got 2 times, 2 different ways of flipping it the first way, 2 for the second coin, and 2 for the third. So each time we have 2 different choices, heads or tails, heads or tails, heads or tails. So it's like we got this tree diagram, we flip, we make another choice, and we have a third choice, and at the end we're going to have 8 different ways of doing this. So let's list these out. So it could be that they are all heads, or we could have 1 tail, so that tail could be at the beginning, or it could be in the middle, or it could be at the end, or we could have 2 tails, and that means that we have 1 head, and that 1 head could be at the beginning, or that 1 head could be in the middle, or that 1 head could be at the end, or we could have all tails. So that takes care of all 8 possibilities. What is the probability of getting exactly 2 heads? So we know that we have a total of 8 possibilities. How many of these have exactly 2 heads? So we can just go up here and look. So where do we have 2 heads? This one has exactly 2 heads, this one has exactly 2 heads, and this one has exactly 2 heads. So that's going to be a probability of 3 out of 8. All right, these questions come from the practice final exam. So again, using some of these more recent concepts of the statistics and the probability. The first question here says, use the frequency table to determine how many students receive a score of 60 or better on an English exam. So Here's the table, and where are the people that scored a 60? So that's going to be here's from 60 to 69 or better, so it could be the 70 to 79 or the 80 to 89 or the 90 to 100. So we have to add these up. 8 plus 3 plus 7 plus 4. And we get 11 plus another 11. Looks like it comes out to 22. So D would be the best answer. Here we're using a box whisker plot. So make sure you put your answer, your numbers here in order. Let's see if we can do this quickly. So what's the smallest number here? Looks like it's 25. So we got 25. Cross that out. And we got a 27. And then we got 28. And we've got a 30 here. And another 30. 33 looks like it's next. 34. 35. Hopefully I'm not missing any. We got two 40s here. 40, 40. And we got the 41. After that, it looks like 45 is next. And we've got the 49. And we've got the 50 and 50. All right, so there's all of our numbers. So first off, start with the easy. So we know that the min is 25 and the max is 50. So all of these have a min and a max at 25 and 50. So that doesn't help us. How many numbers do we have in our list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got 15 numbers in our list. So that means that the middle number is going to be the 8th number in the list. 1, 2, 3, 4, 5, 6, 7, 8. So that should be our median. And that's where the middle dot should be at 35. So this one does not have a median at 35. It looks like it's at 34. The rest of these do. Now we're going to find Q1 and Q3. So if we look at the numbers to the left, we got 1, 2, 3, 4, 5, 6, 7. The median of those is going to be 30. So that's our Q1. So Q1 is at 30. So here, this one doesn't have a Q1 at 30. So that's out. And if we look at the numbers to the right, let's find Q3. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4. This is going to be our Q3 at 45. This one does not have a Q3 at 45. So it looks like B has to be our best answer for that one. Number 3, this is using the multiplication principle. This is like the dinner. So how many different lunches or dinners can we have here? We can have 5 different sandwiches, 2 different soups, and 5 different drinks. So we're going to take 5 times 2 times 5. And that gives us 10 times 5 is 50. 50 choices for that one. Which graph or graphs would be best for showing the depth of water in a pond over a period of time? So if you want to show change over a period of time, well, a pie chart, is that going to do it for us? That's usually parts of a whole. That's good with budgets and time and how much money you're budgeting. So that probably is not a good. A bar graph like this is usually for categorical data, like how many do we have in brand A versus brand B, or maybe these are colors of cars or something. So usually a bar graph is going to be more qualitative data, and it doesn't show the time periods. If we want to know the time periods, we got it right here. Look, we've got the years going down here, and we can see when it goes up and when it goes down. So we can see that, oh, in this period of time, it's going down, and it hits its bottom here at 98, the year 98, and then after 98, the water depth is going back up. So it looks like the third choice here is the best, so that makes C the best option. Use the frequency table. Find the probability that a person goes to movies at least 8 times a month, and we're going to round it to the nearest 1,000. So this is probability, so we want to figure out what we want out of the total. So this one is nice, though, because it gives us the total here at the bottom. So the total we're told is 747. So we Normally we'd have to add up these numbers to get that total, but here they're already added. But at least 8 times a month, where do we find that? I don't see 8 here in the list. More than 7 though, that's at least 8. So that's the same as at least 8. So 5 through 7, 2 through 4, that's not at least 8. So we got to have the 123 here, that's at least 8. That's more than 7. And we're going to take those and divide it. What's 123? 123 divided by 747 gives us 0.1646. So it looks like A is our best answer for that guy. Here's another probability question with a spinner. So again, we think about the probability is what we want out of the total. And we are coming up with a chart here to describe the probabilities for each color: red, yellow, green, and blue. We can see up here we've got 8 sections. So each of these probabilities is going to be out of 8, unless we can reduce it. So let's look at how many reds we have. So from the spinner up here on the spinner board, we've only got 1 slice of red. So that means that the probability of spinning and getting a red is going to be 1 out of 8. So that means that it can't be this probability chart, and it can't be this table because that says 3 out of 8. And it really can't be this one because that also says 3 out of 8. What's the probability of spinning and getting a yellow? So 1, 2, 3, we've got 3 sections there. That should be 3 out of 8. That matches up. The green here, we've got 3 sections of green. That's also 3 out of 8. And we've got blue, which is 1 out of 8. So yes, C is the best answer for that one. All right, so that'll be it. Let me know if you have any questions, and we'll see you next time. Bye.